Hello everybody, Emily Bondar here from Mrs. Abraham's 5th period chemistry class. For my project, I used the program Explain Everything to illuminate the facts and examples of moles and their importance in chemistry and in everyday measurements. The beginning of the study of moles starts with Avogadro's number, named after Amedeo Avogadro, an Italian scientist whose major contribution was to the molecular theory, which is now considered Avogadro's law. Avogadro's number is 6.02 times 10 to the 23rd in moles. Now, a mole is defined as a standard unit for measuring large quantities of very small particles, such as atoms. Each mole of every substance is the same. There's the same number of atoms in each mole, but they have different weights. You have to consider the substance's molar mass. A mole of any pure substance has a mass in grams equal to that of the substance's molecular mass. So, for example, pure oxygen, or O2, has a mass of 16 grams. So, 1 mole of O2 will have a mass of 16 grams as well. In comparison, something like gold, Au, has a mass of 197 grams, so in 1 mole of Au has a mass of 197 grams. But regardless of what the mass is, 1 mole of each still contains the same number of atoms, 6.02 times 10 to the 23rd. For an example, say you're trying to find how many moles are in 15.5 grams of carbon. So you're going to make a table and write the given information right here, 15.5 grams of carbon. Then you have to write your conversion factor, 1 mole, which you're trying to turn it into. And you write, since you're trying to find how many moles in carbon, you're going to have to put the molecular mass of carbon in the last section, 12.01 grams. Now, you're going to divide 15.5 by 12.01, so you can cancel out grams carbon, and the answer you're going to get is 1.29 mole carbon, or 1.29 moles are in 15.5 grams of carbon. Now, if you're trying to find out how many atoms are in 15.5 grams of carbon, you're going to take that previous answer and multiply it by Avogadro's number. So 1.29 mole times 6.02 times 10 to the 23rd mole C is going to equal 7.77 times 10 to the 23rd atoms of carbon. And that's how many atoms would be within 15.5 grams of carbon. Now for another example, say you're trying to find something, how many moles are in a combination mixture sort of thing. So instead of just one element. So say you're trying to find how many moles in 5 grams of H2O. So you're going to write 5 grams H2O, and you're still finding moles, so you can write the conversion factor right here, mole. And the mass of H2O is 18.02 grams. So, like last time, you're going to cancel the grams H2O and divide 5 by 18.02. You're going to get 0.28 mole H2O. And that's how many moles are in 5 grams of H2O. And now if you're going to try to see how many atoms are in that, you're going to do the same thing as last time. You're going to multiply 0.28 by Avogadro's number, which is, again, 6.02 times 10 to the 23rd. And the answer you're going to get is 1.69 times 10 to the 23rd atoms of H2O. That's all for today on explaining moles. Thank you so much for watching.